So, hi, I'm Hana. This is my cool email. I work for Woven by Toyota. We are hiring, by the way. And we want to try to revolutionize how software is done and made for cars and mobility for humanity. We have a lot of C++ positions, Rust positions. There is a lot of stuff to do. So, I'm Hana. I'm software engineer in Woven by Toyota. And I'm also chair of Reflection and Compile Time Study Group. And also, I'm co-chair of Evolution. And it doesn't mean you can ask me about Reflection. It means I'm just making sure people are in the room and able to talk to each other. I'm puppeteer. So you probably know me for some past work about CTRE. I was been here in 2018 and 19. Last year, I talked about co-curl wrapper, which is coroutine wrapper around curl. And also, I have like library called cthash, which is Constexpr implementation of SHA-2, SHA-3 hashing functions. So if you want to calculate hash in compile time, this is a library for you. I mean, for me, it was motivation actually to learn about the hashing and the algorithm, so I implemented. OK, but recently, my work is mostly hacking Clang compiler for proposals for stuff which bothered me a long time, and now I have opportunity to fix it. Yeah. And also, I like to learn how things are working. Sometimes I'm surprised that things are actually working. And also, as a support for my proposal and other proposals for changes in the language or library. So how many of you has an experience with a compiler or interpreter internals? Please raise your hand. Oh, I don't have anything to teach you then. OK, Constexpr. How many of you like to write Constexpr code? What I'm doing here. OK, so do you know Clang? There is a component in Clang called expr constant, and it's Clang's C++ interpreter for Constexpr code in one file. It's a whole C++ interpreter in one big file, 17,000 lines of code. So if you change something, you need to scroll down, up, down, and yeah. It's independent of your CPU architecture. So it's able to interpret your C++ code for your target machine in the same way, in the same semantic as your target machine. So floats behave exactly the same as your target machine, and implements C++ abstract machine. So actually, you can think Constexpr is just another architecture to run C++ on. And it follows expr.constant, part of the standard, which is actually a list of things which are a little bit different for Constexpr, which is kind of weird because if you think about it, Constexpr is just different architecture. And we explicitly specify it in standard that it's a little bit different than every other architecture. So it does symbolic execution. So you need to forget about your CPU architecture, how memory works, everything about pointers, yeah, memory values. Everything is a symbol. It is just a symbol. Did you forget about it? So what's your architecture? Guy. Exactly. So we are ready. So when you do symbolic execution, you need to first think about what's a value. And I'm going deep inside Clang because first half of this presentation is things I wanted to hear if someone told me before I started hacking in Clang. It would make things much easier. And I hope after this presentation, you will be able to do some small changes in Clang. So value is a type called APValue. And it can be nothing. It can be initialized. It can be some number, integer. Doesn't matter if 16-bit, 32-bit, 64, 128,000, it will work. Or float of any arbitrary precision and type. It can be array of other values. It can be union of other values, one of. It can be structure of other values, tuple. Or it can be L value, which is reference or pointer. So far, so good. I see nodding. People in back? OK. Nevin raise hand. Great. So what's an array in APValue? APValue contains array. It's a the APValue is a little bit bigger, and it contains data pointer, like real pointer, but that's a magical thing we don't understand, size and capacity. And the data pointer points at allocated array, and you can have multiple arrays. You can have multiple ints, but you can also have multiple different types. Doesn't matter, because it's just symbols. So fourth element of the array can be float, int, doesn't matter. And you have size and capacity. It's like a vector in C++, in standard library. But each element can be different anything. Union. Union is APValue, one of. It's again, for first thing, there is a little bit of code. I actually don't have much C++ code on slides. And we have union with multiple members, and the union is just field, pointer, and value. So it points into AST at the one member, and it contains pointer to value of it. It allocates inside compiler. So every time you use union in Constexpr, compiler will allocate. You don't know about it, but it allocates. So you can have int, or you can have different int. But the APValue itself is still there. It's allocated once and not many times. It can be float, or it can be object, which is just APValue pointing at object, at structure. Structure is another APValue. Let's have this little bit of code. We have structure of circle, and it's three parts: data, number of bases, and number of members. So we have one base here. It's for circle. It's a position. And we have three members: float, radius, color, fill, color, stroke. And makes sense. So data pointer points at 4 elements, because 1 for bases and 3 for members. First is member to the base position. Second is float. Third is structure to color. And fourth is structure to color. And the structures itself are APValues to their own structures. But I'm skipping the middleman, like the 3 elements, and just pointing directly. So float, float, 3 ints and 3 ints. That's how it looks like in compiler if you have structure inside of structure. So if you ever try to optimize speed of your Constexpr code, think about it, what's happening here. It's better to be flat. Oh, what's happening? Oh, okay. Pointer. What's pointer? How do you implement pointer when everything is symbolic? You can point at some value, but how do you address it? What's the address when you don't have like real architecture and everything is a symbol? It's an AST location of the thing you are pointing at. So first, we will go back to it. What can be pointed by a pointer? You can point nowhere. It can be null. You can point to uninitialize object A, some object. It can be initialized. It doesn't need to be initialized. You can point at initialized object, or you can point at array. And in array, you can point at each member of the array. Or you can point past the array. Or you can point past the object, initialized or initialized. You know this, it's C++. It's easy. And but how do you do it? If there are no addresses, can you sort objects somehow by? Can you sort symbols? How do you sort A and B? Source location, maybe. Maybe A and B, maybe by values. Or how do you sort A, B, C? Is there, or maybe it's two-dimensional. So many objects with unknown content. So you cannot compare pointers. That's why it's undefined to compare pointers, because it depends on architecture where they are. So we need to talk about pointer provenance. We have structure with 3 items in it, 3 members. It's item X, Y, Z. And it's just 3 members, 0, 1, 2, X, Y, Z. And we have another structure which contains array of the items and int with count. Does it look like this? There is a problem. If you have pointer for data 8, which is 1 past the end, and pointer to count, it points at the same thing. But logically, they are not the same pointers. Maybe in your architecture, if you didn't listen to me and didn't forget about it, they can have same address, but they are different pointers. So we cannot do this. So differently. So we have items which are only 2 members, not 9. And the first member is array of 8 members, and then we have some other object on top of it, and it has only 1 member, and so. Now we can point at the object itself. Let's say it's on stack if there is a thing called stack, or on heap or somewhere. We can point directly to the object which owns all the sub-objects. But we can also point at the first member of the object. In address world, they have same address sometimes, if they are trivial. But these pointers are different. And inside of Clang, it's like using notation of path, so it's a.0. Or you can, what's happening here? Come on, it's disconnecting. Or you can point at sub-object of the sub-object, and it's a.0.1. Or you can go there. And from each object, you can go always only down to sub-objects. You cannot go up, and you cannot go left or right, only in arrays. But in array, you can also point at the object, sub-object, sub-object. And if you go, you can go from the parent to child, but not to sibling, only in arrays. You can point at the past DZ, but it's not pointed to 1. And in array, you can actually move to left from right. So it's like holes you like light to, and what you can see, and how can you move, but only for like down and in arrays left to right. You need to think about it, because sometimes we tend to think like, yeah, this thing is just on next address, we can just do it. But it's symbolic C++, it's not a thing, it's UB, and Constexpr Interpreter can tell you that it's an error bug, and it will fail. So you can go like this, and you can point at the object in array. You can look at past the array or past the owner, but you cannot never go back. So implementing things like offset off and playing with pointers, it's just playing with fire. It doesn't symbolically, compiler cannot know. But if compiler knows about the provenance, it can help you and optimize things properly. So what's the difference between L value and R value in terms of the interpreter and of our Constexpr magical hardware? Left is on left and R is on right. Technically, there is no reason. It's just R value is just this L value, and R value is just something marked that maybe you will be able to. It will be destroyed soon, maybe, and you can steal from it. That's the only difference. So it's usually temporary, but you can steal from it. Because we need to talk about lifetime. We have global variables, which they are existing from whole scope of your program. We have scope-based variables, which are like local variables in your functions. We have temporaries, which are part of your expressions. They don't even have name, they are just values. And we have also heap allocations, which we have only like some pointer to them. But obviously, heap allocations doesn't behave this way, so it's actually like this. And you can promote temporaries to variables, so it's actually like this. Okay. So you need to think about like lifetime, maybe like this. Maybe some won't agree with me. That is my personal mental model. It helps me to understand code. So identifier of the pointer is its location. So global variables are identified by its name, AST node. It's just a big tree with all the items in your source code, and global variable is just one node in it. And you can have like a real hardware pointer to it. Local variables are identified by AST node and version. You will get there. And allocated values are identified by unique key. So every time you allocate something, you will get unique key, which is actually just counter. So you have first allocation, second allocation, third allocation. It goes like this. So what's the pointer? Let's have this code, coordinates and function with local variables. So we have a variable of 2 items, which is just structure of x, 10, epsilon 20. And we have pointer to the variable itself. It points at the outer object. The AP value is three things. Pointer to declaration of the variable, and a version. And every time you call something or a function, I'm exactly not sure, because it's like a little bit messy, it increments itself. So if you somehow get pointer to some previous version of the variable, it's different version, and it's no longer apply, and it will give you an error. Second, third, 4, 5. And we have pointer to only the variable itself, but we can get pointer to sub-object. We just need provenance or path. We need to look at the .x, so we will allocate path, and it will be 1, 0. It's first member of the sub-object of variable. Okay, and if you want second member, it's just 1. That's it. So, and if we want allocation, let's have like fixed string of 16 bytes or chars. So there is some value somewhere containing the structure. So first is pointer to expression, where you allocated. So if you leak it, compiler will give you nice error. that this allocation started here, which is kind of beautiful. And from the expression itself, you can actually access type of the value itself. And there is a key, which is just some number of the allocation, and every time you allocate, it's something else. Okay. And if you want to look inside, then there is a pointer from structure to array it's in it. So we will go to this first member, and we change provenance, and now we are pointing at the first member, the whole array. And if you want to point at member of the array, we just need longer path, like this. This is a pointer in Constexpr, like Constexpr evaluator in Clang. That's how it's implemented. Okay. You can go past, and there is a special symbol for past the end. Okay. And static variable are actually only two things, which is just like you are pointing at something, and it's implemented as pointer to var declaration. And inside of the var declaration AST node, not somewhere else like for stack or something, the value of x is stored there. And if you have pointer to var declaration, you have also the value. Okay. Where are the values stored? Global variables in AST node, I just show you. And local variables are in kind of like stack-like data structure. So it actually models RII properties of C++. So we just push and pop, and it works. Allocations are in a map where with key. It's actually literally stud map with key of the allocation and value. All you need, all things you need, like what's there and something more. So constant evaluator then just walks AST. You have a tree representing your code, and you just recursively walk and do operations. So if you want to load a variable, you will just, if there is just value, you have value, and if you have pointer, you need to have type of the pointer and look for it and access it, and then you have value, and you can put it into expression, and then you can store it somewhere else. It's actually kind of really easy once you see it. There is no bytecode, nothing. It's just AST, and you are recursively walking it. And this is all implemented in C++. So we are implementing C++ in C++. And sometimes it's really confusing. Because if you want to implement something, some new feature, let's say exception, it helps me understand C++ machine. But if you want to implement some feature, let's say exceptions, the best feature to implement them is the feature itself. So my first try when I was trying to implement exceptions was just use exceptions and use them for underling. And the interpret can also detect every violation with star of the abstract machine. They try really hard. There are a lot of checks. If you are accessing pointer, if it's alive, and etc. They are trying really hard, and it's mostly, sometimes it's bothering me because I want to actually break something, but it makes kind of safe C++. So you can say Constexpr C++ is safe, kinda. I know Titus is shrugging. Yeah. So Constexpr Interpreter is just another machine C++ is capable of running on. So most of the standard library should be constant evaluable. Do you agree with that? I mean, most of it. We talked yesterday with Titus that all parts which cannot observe out the universe. So time is like not a thing. I/O, in some sense. Networking, never. But so it's like sandboxed. So you can do repeatable builds, and you will get always same answer. Then it's fine. But most of the standard library is not Constexpr compatible. Instead, there will be a small quiz time. It won't be that funny as yesterday's. So, what about containers in standard library, which are Constexpr? Is array Constexpr? Raise your hand if you think it is. It's morning, I know, we are sleepy. It is Constexpr. For a long time, array of size 0 was problematic on some platforms, but it's now Constexpr fully. Deque. Is Deque Constexpr? Can you use Deque in Constexpr? And for the record, Guy Davidson, who is member of committee and library evolution chair, thinks it is. It's not. Yeah, I'm sorry. I'm not, actually. Flat map, it's a new data structure. Is it Constexpr? Do you think so? It will be in 23, 26, 26, I think. Yeah. So I need to actually see the hands if you think so. No. It's a new feature and it's not Constexpr. Why? Flat set. Obviously, it's the same thing as flat map, so that one was easy. That's on me. I should forward list. It's just linked list. Is it Constexpr? Why not? It's not. It's weird. It's the simplest data structure, the most stupid data structure, and no. Inplace vector, new data structure in C++. So who think it's Constexpr? It is, but with asterisk. Only for trivial types, trivial Constexpr types. Because we don't know how to make them Constexpr for any Constexpr type. Trivially constructible types, sorry. Hive, new data structure, which is going to 26. It's useful for games and networking because it gives you stable iterators. Is it Constexpr? Just let it sink. Is it Constexpr? There is a section in the paper. Kevin, do you think? Yeah. For record, Kevin is not member of the committee, so he can be mistaken. Sorry. Hive is new data structure, and there is a section in paper discussing if it should be Constexpr or not, and the author just gave up and said, I'm not doing this, I don't need it. So it's not Constexpr. What are you doing in library evolution? I don't know which things. So, list. I mean, yeah, again, forward list, so list will be weird. No, it's not. Map. I mean, you are getting the game, obviously. So it's not. Optional. It's a data structure now. It has begin and end. It's a container. Yes, it is. It's a one or nothing. Set. Nope. Yes, you are correct. Basic string T. It is. One of you. Another map. Nope. Another set. Nope. Val array. People usually forget about val array it exists. I mean, there is a proposal about bringing simd into C++, but we already have simd at home. Oh, no. Vector. Yes, it's widely known. It's Constexpr. Do you know why we have a situation like this? Peter, we will get there. It's rhetorical. So yeah, sorry, we need to look at some containers in details first. Stat array. is just array of n items, and let's say 11 items. And when you construct it, it will initialize itself. And if you don't provide enough elements, it will default initialize itself because it's on stack, so it needs to be initialized anyway. And then you can have like iterator to begin, or end, or iterator somewhere in middle. And because it's array and provenance allows you to move around, so you can move around or one element or multiple elements, and you can edit it. And iterators are stable unless you move the array somewhere else, because the storage itself will be somewhere else. You can move around. It's just array. Oh, what's happening? I should go here. There's no signal here. OK. And when you destroy it, it goes backward. It's a well-behaving citizen, and it just create like it's LIFO, last in, first out. It just destroyed elements nicely, and then itself. Vector. It's three pointers, data size, capacity. It can be data and 2 numbers, but it is 3 pointers. You allocate some number of elements, and you can put it. This one is empty, but with capacity 4. You can put one element, another element, another element, another one. And when you are full and you try to add another thing, it will just allocate twice size usually in most implementation, most sane implementation. There are some implementation which allocates like 1/3 more for some reason. You can guess which one. And and then it will move elements to new one. But if there is an exception and it's not safe, so it would like mean that you already moved your elements, they are moved out, and you got inconsistent state. So if the moving is not exception safe, you cannot do it, then you need to do copies. So start again, and you will do copies. And once you are done, then we change pointers, and we will destroy the items on the previous one, and they are destroyed from front, not from the back. That's like vector behaves differently. There's like no signal. No. So, and then we have new element with capacity of 8, and we can put few more elements in it. And we have iterators. And once you put something in it, are iterators stable if you put something here in it? But raise your hand, don't just note or something, because I cannot read it. So are iterators stable? If I put something now, can I use iterator? Kinda yes, but can I observe when the allocation is I can check by capacity, but so you shouldn't. It's not safe. Because if your capacity was different or your implementation was different and you expect that there is something still or didn't check, then now, but once you move stuff, the iterators will explode. So no, every time you modify vector, you cannot use its iterators. And then we can move out if it's safe, so we can move out. And then we can destroy it, obviously. And then we can add a few more items. And then we can have iterator to element, and we can destroy it. How do you destroy, erase element from vector? You move it at the end. It's ON operation. And when you are at the end, you make size of the vector a little bit smaller and destroy the element. So the destructor actually destroys different element than you destroying. It can be surprising sometimes. Or you can erase some range of items, and then you do something similar. Just push them like this, and then you destroy number of elements you erased and change size. It's vector. It's simple. It's Constexpr, and it's quite complicated. And then when you destroy, you are going again from the front. Okay. List. Someone wise yesterday told me, don't use list ever for anything. Titus. List, if you create one element, you have front and back, and element contains 2 pointers. In some implementation, it can contain only 1 pointer and use some XOR magic, but it's not like symbolic, so don't do that. And you have one element, you can put on back, and it does this. You have pointer to previous and next always, etc. You can take iterator, and iterator is stable even if you are changing list. So maybe if you have like really big chunks you need to put as an item in a list, then it's useful. Otherwise, you are allocating a lot of small objects, and it's not great. You can create new one. Or you can also destroy from the back or destroy from the front. Or you can destroy from middle. So you just take iterator, it will take iterator, and it will destroy middle element by changing the pointers first. And iterator moves to next element, and it will delete it. List is not Constexpr. Do you see any problem with making it Constexpr? I don't. Inplace vector. You have like 4 items in vector. You can put it. It's just an array with number of items. You can put it there. Works so good. But even if you have only 4 items, rest must be default initialized because it's on stack, and it must be initialized. And if it's not, then it cannot be Constexpr. Because Constexpr is much more strict, and runtime C++ doesn't kind of care. So if your type is not default initializable, it will fail to construct. It will give you error. It should be possible. No, Deque. Deque is like 5 members. You have prefix capacity, suffix capacity, and pointers like vector in middle, and each item in vector itself is just pointer to leaf. Leaf is fixed sized array, and you can other in front, other in back. You can remove from middle, and so if you putting creating items at the end or beginning, it's all one operation. And if the vector size is no longer has any capacity, it will create need to allocate, but it's on of number of leaves. It's kind of cute data structure if you want stable iterators and you want to allocate big chunks. It's better than list, definitely. Why are you not using it? Did you ever use Deque, other than as in stack or queue? And do you know, on some platforms, it will give you only 16 bytes or 2 elements, whatever it's smaller? MSVC. Sorry. So that's, and they cannot fix it because ABI. So Deque is basically useless on Windows. It's just linked list with vector, so it's like with some additional like overhead. So yeah, these all seem implementable in Constexpr. There is no reason to not have them in Constexpr, with like caveat of the in-place vector. They should be Constexpr. But why is only vector and string Constexpr? Special points for anyone who knows why. Peter, you maybe know. I probably told you. Yeah. Like potential answer is it was needed. Louis, are you in the room? Do you know why? Someone needs to write paper. And someone, you wasn't there on the colon meeting to push it to library. So vector and string got into library thanks to chocolate. I bribed Marshall to put it in the last possible slot because I really wanted it. But there is no other reason to not have any other data structures Constexpr. I think you all agree. And if you take only one thing from this talk, you should agree on this. Everything should be Constexpr. C++ language is improving with every version. So we will get better, but it's a lot of work, and we need to push papers and go through all the bureaucracy and convince people that actually there is a motivation to have Deque Constexpr. For me, myself, I don't need motivation. I just it's obvious it should be. It makes language and library easier because you don't need to think what is and what's not. You should have only simple rule, like I said before. You cannot observe outer universe, and then it should be fine. Well, again? Come on. So, some Constexpr limitation, and when they were removed. Do you remember that you cannot use if, for, and while in Constexpr? It was a long time ago, but it feels like yesterday somehow. It was C++ 14 which allowed it. At first, because it was just constant expression, not like anything more. Variables. There was a time you couldn't use variables other than parameters in Constexpr. And if you think about it, if you have parameters, you have variables. So again, C++ 14. Calling lambdas. Actually having lambda and calling it in Constexpr code. Do you know when? We think it's 11 from the beginning of Constexpr. Raise your hand. There is one hand from my former coworker. And C++ 17. It took a while, but we got there. Trivial default initialization. So you don't need actually to write equal value of the variable explicitly. Which version of C++? So OK, 11, 14, 17, OK, 20. Yeah, you are correct. OK, try catch. 11, someone, 14, someone. OK, so let's go in another direction. 23, 20. You are correct, 20. You can have try and catch in code, but catch will never be evaluated. So if there is an exception, it's directly failure. Changing active member of union, not just initializing, but changing it later, which is really useful for a lot of data structures. 11, 14. Come on, people. 17. OK. 20. 23. 20. Inline assembly. OK, 11. 14. 17. 20. 23. Or 26. Just for the record, the answer is 20, and Titus got it wrong. but only for unevaluated. You cannot evaluate it. So originally, Constexpr was designed that if you put something as a Constexpr, every possible code path must be Constexpr. That was original intention, unless recently. Now, since 23, since 20 actually, if there is a path which is not Constexpr, it's fine. Maybe there is no path which makes it Constexpr. And you can still mark it as a Constexpr. So it's kind of like opt-in now, not just guarantee. Atomic operations. I know there are no threads in Constexpr, but you should be able to use, because they are like semantic of normal, like mathematical operations. You should have atomic operations. 11, 14, okay, 17. Okay, interesting. 20, 23, 26, 29. As of today, since this morning, it was passed to library working group to 26. Yes, it's my paper, by the way. Exception throwing. Actually throwing exceptions. I kind of spoiled it with try catch, but as of this morning, also it's in library working group and in core. It's in core for a while, so yes. Maybe 26, hopefully. Using byte array as object storage, which is a really useful feature, but I think I know how to do it in Clang, but I need to convince some other implementers that it's worth pursue. So no. Reinterpret cast. There are valid use cases for reinterpret cast. I mean, reinterpret cast is like utility folder of casts. You put there everything you don't know where to put everything else. So like there is a case when you can, if you have trivial types and you have pointer to first member, you can safely, by language design, cast it to its owner, to its parent type. Or you can pass it between like pointer convertible types. So you can have type and pass it to bytes, but not in Constexpr. In Constexpr, reinterpret cast is disallowed on syntactical level. It cannot be there. And cannot be evaluated. So virtual functions. C++ 11, can you use virtual functions in Constexpr? C++ 14, 17, okay, 20, 23, 26, 29, no, it's 20. Virtual basis. How many of you use virtual inheritance in past 5 years? I'm sorry. No, it's not Constexpr. It's there was a long time ago. No, just recently, there was a list of things you cannot have in Constexpr, and we are slowly removing in. And if we remove some stuff, virtual basis will be probably the last thing which is not allowed in 26. Because no one cares, no one wrote paper, and I didn't know it's still not allowed. So Constexpr still needs some improvements, but we will get there, I hope. So what's my favorite data structure? Because it's talk about data structure, and APValue is a data structure, pointers are data structures. So what's my favorite data structure? What's yours? Guy says vector. Also vector? There was a rhyme in standard. If you don't know better, just use vector or something like that. It was recently removed, but we are working to get it back. Yes, we will need to cut this out. So someone says map. But also, I would like you to think, what's your data structure for yourself or algorithm? For myself, thing which take me to programming was, I think in 2nd grade, we were on day trip to a local library, and they showed me at the time paper indices of the books. And they are sorted by name or author, and you can actually do the algorithms when you look into half and binary search, and I was like, wow, it's got me in programming. So for me, it's like just binary search, but favorite data structure. It's also motivation for all my work on Constexpr, because I try to implement it and I run into some issues. So I'm trying to fix that, and once everything is fixed, I'm going to your room with this data structure, and I'm not leaving. So the data structure gives you O1, insert, search, and delete, or updates also. That's cute. Maybe hash table? It has linear growth, unlike hash tables. So you don't need hashing. It can be log-free if you want. It can be persistent. And Phil knows. It can be usable in a flat storage if you use offsets instead of pointers. It's called HMT, hash array mapped Trie. It's all buzzwords together. It's cool. And it was invented in 2001 version and log-free in 2011, actually. It's a new one. Anyone here in this room could invent it because it's simple. So you have a root element, which is like something owning the data structure. And you have a leaf. It has hash, some sort of hash function. You need hash function, which calculate hash of the key of the leaf or value you need. In this case, it's 4E8F. So you have level 1, and you have, in this case, 16 items in the array. And you use first 4 bits of the hash, because it's Trie, to look for level 2, and use second 4 bits, E, to look on level 3, and 8 of level 4, and F to actually look for the item. That's the idea. You can obviously have more items, so it's like kind of tree, which is much more wider, like this. You can also have leaves which are not going all the way down. If there is no conflict of hashes, you can just put it there, or even to level 1. But you need to distinct when you are going to next leaf, or leaf or level. So you need pointer tagging for that. So you need to put 1 bit information to the pointer that is going to leaf. Next to pointer, it's like 1 bit information. This is not pointer to level, it's pointer to leaf. And every other pointer there is just without the bit, obviously. You can have multiple items in the leaf if they have some hash. Then you need some numbers, but I won't show it here. But it's wasteful because there is so much empty space. You can compress it. And only store items you actually care about. And in front, you put bitmap with items you actually stored. And you can use pop count to calculate from the index to the real position. So the bitmap. Suddenly, it's much smaller and nicer. But you need variable size objects and stuff like that, or some tricks. But this can be done now in Constexpr. Or you can change all pointers to atomic pointers, like atomic pointer to first level, and you have like another object with atomic pointer to the next level, like this. And also for leaves. And you change the pointers there. And you can exchange them atomically in log-free fashion. Sometimes you just need to repeat your action if you run into conflict. Or let's make it simpler, so remove them. And you can also put a ref count there into nodes and leaves. And then you can have multiple versions sharing unmodified data between versions. So it's persistent. So you can have multiple versions, and they are sharing. So you can actually have like in binary static version, and then you can have only like overlay. Simple. Or if we remove the, and for simplicity, we will remove the ref count. You can also replace all the pointers with offset and write it from down to top into storage and put it into flat storage like this. Maybe file. And it's still same data structure. And if you have view to only part of the storage like this, you have one snapshot or another snapshot. So if you update it, you have like snapshot, and you are modifying the data structure only by addition, so it can be useful for transaction logs. Yeah, that's my favorite data structure. But it needs some requirements like pointer tagging, variable-sized objects, atomic operations, byte storage for objects if I don't have variable-sized objects. But we are getting there. There are a few papers which will get there. Exception throwing is my paper. It's not needed here, but I'm proud of it. Also, additional Constexpr exception types. Constexpr atomic refs. It's in library. It's Constexpr shared pointer. Also, it should be Constexpr. There is no reason. Pointer tagging. You need some functionality to tag pointers without using an interpret cast, because an interpret cast is, you cannot see in code what's happening there. So it should be something named, some library functionality which actually says tag pointer or something. So you understand what's happening, so you can reason what's happening, and you don't need to understand the bit fiddling of pointers of your architecture. Trivial unions. You need to, like, this is a proposal from Barry Revzin, which allows you to have initialized items on stack. So inline vector will allow to be Constexpr even for non-trivial constructible types. Constexpr containers and adapters is paper of mine, which makes all the containers, with the exception of Hive, Constexpr. And it's only because I was looking at the current draft and Hive wasn't there yet. Freestanding Constexpr containers and Constexpr exception types. I forgot his name, sorry. Paper which makes Constexpr containers and exception types available in freestanding environment. Only for Constexpr, for constant evaluation. So in embed world, in automotive, you will be able to use vector and everything in compile time to build your data, and then, but in runtime they won't be available. That's kind of useful, I think. Constexpr coroutines. Is there any reason why coroutines should be Constexpr? It's just another flow, and we just didn't know how to do it. Like, we knew it's like obvious because it's exactly the same as on a real processor. So we just need to specify it, and we were playing too safe, let's say. Constexpr stat format. Stat format doesn't work in Constexpr, and there were papers like static assert when you stat format error message, but you cannot use stat format because it's a Constexpr. It should be. Constexpr stat generator. If you have coroutines, it should be also generator, so you can actually generate things in Constexpr. And there is a paper, it's draft only because Jeff missed deadline, about non-transient Constexpr allocations. So you will be able to allocate in Constexpr like object like unique pointer or map or vector and return it into runtime as a static object or static Constexpr object. And it won't give you any overhead in terms of construction of the items. It will be just there. So with the data structure I showed you, you can have calculated some story, some data structure and data in it in compile time, and then in the runtime you will just create overlay with it. It's cute, and it works simply, as I showed you before, how the pointer works in Constexpr, because you have dynamic allocation, which is just identifier of the allocation, and it will just upgrade the allocation itself into static pointer, and it creates artificial static variable and put the AP value of the object there. And it will go recursively and change all the pointers accordingly. And that's it. And if there is still some allocation which is not reachable, then it's error. But if it's not, then you have vector as a Constexpr variable or as just static mutable variable if you want. And if you combine this in future with Constexpr coroutines, you will be able to run coroutines in compile time, suspend it, and resume it in runtime. Thank you. That's my favorite Constexpr data structures. And we have time for questions. If you have any, please do have some.
So for the standard containers, we are evaluating all the Constexpr code that is in the standard library at compile time.
Yeah.
Would it be beneficial to have an optimization where we already know that the standard vector is working like that and optimize it not to reinterpret all the AST?
Maybe, but it will add more work for compiler developers who are busy implementing other stuff. And it will be just performance optimization. It won't change behavior, and it will be hard for library vendors because suddenly, if there is a bug in it, people will go to library vendors, hey, vector, it doesn't work, but they will say, no, it's not ours. It's actually compilers, and it will be hard to debug. So there's some distinction. I think the library and language should be more intertwined. Yep. People from the rooms don't talk to each other much, but it should, yeah. But it's easier if it's just in library. There is actually work in Clang. They are working on different interpreter for Constexpr, which is bytecode based. So you do some translation, and it's like 100 times faster. So maybe you won't need it.
And then the next level would be to have a JIT compiler.
That's exactly okay. That's exactly, yeah.
Sounds good. Very good talk. Thank you.
Thank you.
Now, if we talk about the things which we can't make constant expressions like file system, could we add like mocks to the standard to have that available?
I think there's like, the line is a little bit blurred. You should be able to observe universe unless the resource is explicitly given to you. Like as the dependency. So maybe you have file and you are programming a game and you have like some resource file. Then if your build system understands it, that is the resource you are accessing. So you shouldn't be able to like create, construct a file name and access it just randomly. That would lead to malware probably or some security problem. But if you explicitly access some like item file as a resource, then I think it's totally fine. Even some more like if you like, you can like create multiple artifacts, like not just object file, but maybe even some like resource files next to your binary as a part of your calculation. It's still fine. You should be able to just nothing should break repeatability of your build. If the promise is broken, then it should be Constexpr. Otherwise, it's fine. But by design, so by like design of the thing, not just like if you don't do this, it will work. No, it should be by design, not allow you to break build.
Okay.
Thank you for the talk. Do you have some tip how to debug Constexpr code? Do I have to memorize this 17K file and build Clang in debug mode?
Okay. You can, if you want, like to join debugger to your compiler and make sure it will actually not fork because Clang is also forking. So actually attaching to write binary is hard, or to write process. But I don't recommend to look at the compiler because you will be actually looking at the machine itself, and like you would be like looking at bits on a register. You need to like going a little bit higher, and there is no such tool yet. There is a like space for such tool that maybe like debugger which could attach to it, but it will be hard. And I will tell you a little secret. Don't repeat me, please. Compiler developers love print for debugging. So I, for my, when I'm like hacking Constexpr, I create a built-in which prints during compilation stuff. Because I can.
Thank you.
You're welcome. I'm sorry.
So questions are loading. Online questions. David 4 asks, is there a reference implementation of the HMT data structure? Is there a plan to make it part of the STL?
There is multiple implementation. They are definitely not Constexpr. They are mostly like C or academical code. Phil maybe know better. Phil has implementation. You? It's unfinished. Okay, there are like I'm working on several of them because I always start and then never finish. But I will get through because I will slowly get all the features needed, and then I want to go to library evolution and bring it to standard because it's really useful data structure. It's really flexible. I know that people will agree that it's too new. It's just like 10 years old or 14 years old, but it's really useful, and it's really hard to implement correctly. So I would love to see it in standard.
Okay.
Hi, thank you for the talk. You have highlighted a series of grievances with Constexpr, like for example, this should be Constexpr, but it isn't. You have also highlighted your extensive work within the standard, so you know how the processes work, etc. Do you have any lessons that we could learn, like for example, for developing new feature, for lessons that could be learned from how to avoid problems like the ones you have highlighted with Constexpr, with newer features and lessons abroad we can learn?
I think there should be standing policy for library. I'm looking there. That everything which is going to library should be Constexpr unless it's really impossible, like it's breaking the promise that is observing universe. And you should ask a question, why did you implement it as Constexpr? And if so, do you need something which is not in language? If so, go to evolution and make it happen. It's kind of like sad that we are like currently like 13 years since C++ 11, and still we need to like instead of going once with one thing flat map and making it Constexpr right away because it's based on vector, so it should be. There is no reason to not be. So we need to go twice. It's just overhead.
Thank you.
Fernando Iglesia asks, excellent talk, thank you very much. That's a statement I can agree with. How does the model with pointers to nodes of the AST help in challenges like the provenance with respect to traditional pointers representing memory address?
Okay, if I understand correctly, the question, you have much more information about the pointer. Pointer is not just address, but actually you know which is the main object, if it's on stack, on heap, and also which exact subject you are looking at. So it gives you much more information, so you actually know all about the boundaries around it, and so it's, I mean, it's heavy, so it's not possible to do it in a runtime without big overhead, but it has a lot of information, and thanks to that, at least in Clang, we can guarantee that using pointer won't lead to any UB. So that's also the reason why you cannot convert pointer to number, because it's a structure, it's not a number. So that's all. That's just more information.
Mm-hmm. For someone having no experience in compiler development, how can one start and contribute to Clang LLVM?
Okay, that's easy, and I hope everyone will here do it, because Clang needs more developers. And if you have something you want to fix in Clang, just pull the source code from GitHub. It's open source. Personally, when I'm starting fixing something, I just write code as I want it to work, and I will get error message. Then I will look for the error message in Deque TD, and from there I will find a place where it's printed in this source code. And then I will look around what can be fixed to make it happen. I mean, 8 months ago, I actually started hacking Clang during Tokyo meeting out of spite. Because someone told me that it's not needed and they won't do it, and there's no motivation for exceptions. So yeah, I started implementing myself, because I think it's a really useful feature, and I learned all that myself. And this talk is mostly things I wanted to know when I started. It will be much easier. Sorry, it's blinking.
Hana Dusíková asks, just curious, and I would like to know the tool which you create the slides and diagrams.
Okay, yeah, that's a question I'm getting a lot. It's Reveal.js. It's JavaScript library. I love JavaScript. It was last year on my one slide. But for the animations, it's actually my own animation engine. I call it Hanimation. And it's just like you can control it, program it with JavaScript, and you can do whatever you want. And if it's not there, I can just add it there. It's not open source. I don't know if it will ever be. It's messy, but it does the job done for me. Maybe someday. As I love the result. I'm really proud of it. Thank you.
A question from Jean-François René. Can a constant expression function throw an exception, and how does Constexpr interact with templates?
Okay, first part, if you can throw exception in Constexpr. Did I hear correctly? Currently, no. There is my implementation on Compiler Explorer. You can play with it based on the paper number, which is P3068. It's there. There are some problems around exception pointers, but it should be polished soon. So in mainline Clang, no. In future, yes. And in future, it will be in all compilers. It's going to be kind of funny because you need to change behavior of -f-no exceptions. Because suddenly exceptions will be allowed syntactically in source code. So there will be some changes. And the second part of the question, I'm not sure if I understand correctly.
Well, so constant expression is at compile time, and how does this interact with templates?
Not at all, because templates are like, every time you instantiate templates, they like instantiate itself. It's like it's a template, so it will like create all the AST, and then during the instantiation, it can call a Constexpr function, but it's new call, and if you throw exceptions there, I will for the exceptions, then the instantiation will fail. And you can use that to give actually nice error message from the exception during instantiation. And the error message of what member of the exception will be printed as a nice error. So you can actually like set, I cannot instantiate this template because value provided is not divisible by 2. Which is much better error than it fails because Finae checks somewhere else. But otherwise, templates and Constexpr are not related, but you can use Constexpr function as a like in expressions during instantiation of the template.
Okay. Actually, while I have you here, I wanted to ask you if my understanding of constant expression string and vector is correct, that you can use it to do stuff at compile time, but you can't preserve it for runtime.
Yeah, currently you cannot do a non-transient allocation. So every allocation you create during constant evaluation, within one constant evaluation, so if you instantiate something, then it's new to constant evaluation, the allocation cannot leave. You must free everything, and otherwise it will give you error. So there is a trick how to do it. Like you can return array instead of vector of that size, and you will do two passes, one to calculate size of the array, and then to fill it. So like Jason Turner has like a lot to talk about this like approach. Or you can just allocate a big array and return it, and don't care about the rest.
So, Guillaume Dua asks, do you use a specific dedicated test framework to create unit tests for constant evaluated code, or do you only use static asserts?
You can do both. When I'm developing implementation, I'm using test suite of LLVM and Clang. If I'm writing my own code, I'm using Phil's Sketch 2, which is awesome, and you should use it. And if you are not using it, you should now.
I didn't read your paper, but will we have backtraces for exceptions as well?
It's not defined in standard. Implementation can provide it. Actually, if you current status quo, if you have exception, you will get long backtrace of the errors from the exception itself. But I think by default you shouldn't see them, because usually such errors are inside of library, and as a user, you shouldn't care about implementation of the library. So, for example, my library CTRE, if you provide wrong regular expression, it shouldn't give you long error message that somewhere else it failed. It should give you a nice error message, hey, you missed closing parenthesis.
So these are two contradictional things, because you assume that it's not my code.
Yeah, if it's your code, then there should be like flag in Clang, which will give you also the stack trace or in compiler. But standard doesn't mandate anything to show like even now, if it fails, standard doesn't say you should see backtrace.
Okay, to be more specific, if I catch an exception at compile time, will I be able to get the backtrace from this exception?
That depends on implementation. That's not. It's not a thing in standard. There is no like backtrace, like there's stack trace now, but I mean, do you mean like data type? If you catch it,
We have the backtrace thing in standard now.
That if you create it at the moment when you're throwing and then store it into exception, and then yes.
And it works with the compile time execution stack.
Someone will need to make stack trace Constexpr compatible.
Okay, so we don't get that.
Not yet. I mean, everything. Everything which happens in C++ and in committee is volunteer based. So if you care about it, write paper, and it will happen. Otherwise, there is probably no one who cares about it enough to write paper, because people are busy.
So do you know if this data is available inside of the compiler? Because I would
Yeah,
assume
they definitely are.
If you call a function inside of a Constexpr-related thing, then it might be Constexpr as well. Then it's
the information is there. Don't worry, it's there, because now when you get error, there is the backtrace. So information is there. It's possible to get it if you change Clang, but not yet.
Okay, thank you.
Sukasan asks, just curious, may I ask if Woven by Toyota is using latest C++ standards or is allowed to use due to automotive coding standards limitations?
It depends where. In the most critical stuff, we are just migrating to 17. And in non-critical stuff, we can use newer things. And our mission is actually to make development in embed space safe and based on all the standardization and stuff. But you should be able to use latest tools, because they give you much better tool and guarantees than the old one. That's our mission, kind of. That's how JF sold me this.
Okay. So, just general question to the room. Oh, there we have.
Thank you for a very interesting talk. I have maybe a general question. Are there any measures on big code bases how much the constant expressions could help there? Like how many of this code could be constant expressed in the compile time? In general, I would like to understand if all the push for making everything constant has what is like a real world benefit.
The real benefit is that you can actually do as much as you can if your inputs are constant and user defined by runtime.
Yes, that's I get it.
There is no measure. No one does that. I like to not have code in my binary which I don't need to.
Yes.
But I wrote the regular expression engine for that, and so I don't need parser for regular expression in my binary. I just want to parse much text. So generally, it helps because compile can actually see the result, and it won't optimize based on that, but it will fault, and then it will optimize on the fault version, which is simpler and easier to understand for compiler.
Okay, thank you. But in general, I want to just say that if there's like a more like a academic endeavor to have everything constant expressed, or there is like
it's definitely not.
Like everybody is like in. That's basically are aware of big code bases that they say, okay, we really need this because this will help us in this, that, and that. Yes.
It's useful. It's hard to imagine because it's some new way of thinking. 14-year-old.
Okay.
But before that, we had template metaprogramming, but I saw it in embed firmware. If you have Intel processor, probably in firmware, they are using Constexpr to build the firmware. I saw talk from Bendin and CPP now this year when they actually use Constexpr and some tricks to actually allocate everything statically for all the asynchronous operations, so they don't need any allocation and they know exactly bound how much they use. So they can actually know in firmware how much memory they need, and if they are going to pass the limit, the compilation will fail.
Okay, yeah.
That's super useful.
I'm checking. Yeah, I get it. Thank you.
Xavier Ventura asks, how do you test constant expression code? Do you just use static assertions?
You can use static assertion, or you can use any test framework, and you only need to force the constant evaluation. So you need to use Constexpr variable, so it will compile time, compile during compilation. And if it fails, if there is an error, the compilation will fail, but you still need to check the result. And for that, you just put a Constexpr variable into cache, and then just write requires equals expected result. And it will give you a nice report. If it fails, then it's a problem, and you need to fix it. But you can test it. Other problem is actually measuring code coverage of Constexpr. And I think there are some people working on that in our team. So you can actually measure code coverage even for Constexpr code.
So one thing I've just been wondering about is what are easy arguments to tell your manager to do stuff more at compile time, and what is our benefit to stuff that non-technical people can understand to your project?
You need technical knowledge manager, not pointy head boss. And you need a manager who will trust you. As Titus said, you need someone who actually trusts your technical judgment. And if you are my manager and you trust me, and I'm going to you, hey, we need to do this, it will help us. You don't need numerical, statistical argument. Then it should be okay.
Okay.
Okay, that seems we ended. I mean, I will show you one small thing. I will open it here. Here, for example, for the exception, if it opens, I don't have internet, so it doesn't. Okay. The wording itself to allow exceptions. This is older version, but it's simple. Just remove limitation for the exception and other definition that all the exception cannot leave constant evaluation. And that's all. And you have C++ with exceptions. And thank you.
Yes. Thank you very much. Great keynote.